Thank you, Julia, and thanks also, Nigel and John, for the excellent warm-up. And I am going to try and respond to what came up in the Slido, because whilst I'm going to talk about the bad climate tipping points and some of the uncertainty around them, I also want to cheer you up at the end, and I'm going to talk about the positive tipping points we need to propel action to decarbonise rapidly and limit global warming. So I'm going to start with the big picture. So this is the last 650,000 years of what atmospheric carbon dioxide in blue and temperature in white have been doing, and then us pushing the CO2 level up there. Before we industrialise, that natural behaviour of the Earth's climate, it shows that even without our activities, the climate isn't that stable in the big picture. What we're seeing there is repeated ice age cycles. And at the end of each ice age, when the temperature and the CO2 level went up abruptly through purely natural mechanisms, there were amplifying feedbacks in the climate. And one could almost say there were tipping points in the climate system where ice sheets collapsed rapidly, temperature rose around 4 or 5 degrees centigrade, sea level ultimately rose about 120 meters at each end of each ice age. And it's against that somewhat unstable climate backdrop that we've taken the CO2 level to about 410 parts per million. And in the rest of my lifetime, could well double it from the pre-industrial level and push 600 parts per million. And seeing the correlation between CO2 and temperature in Earth's recent history, we shouldn't be surprised that there's going to be some quite profound consequences of doing this. So I am going to talk about what tipping points we might cross in the climate system, what abrupt changes we might trigger. But I also want to dwell, before we get to that, a little bit on what this means for people, because as we warm the planet up this century, we're talking about anything between a rise in the best case scenario of 1.5 degrees centigrade warming above the pre-industrial level, or in the worst case scenario, something more like 5 degrees centigrade warming, as big as the difference between the ice age and what we call the interglacial. Our best sort of guess at the moment, based on the national determined contributions of all our different countries, is that we're heading for about 3 degrees C of global warming. But in terms of what that means for the average temperature experienced by the average human, it's actually going to be more warming than that, because people live on the land, which warms faster than the ocean. And also there's an effect that most population growth is happening in an already hot place, sub-Saharan Africa. So we did some work earlier this year where we looked at what a 3 degree warmer world would mean. In particular, I'm showing on this map how the really hot conditions, a mean annual average temperature of 29 degrees centigrade or above, which is currently experienced in the black areas on the map here, a few spots in the Sahara basically, how those temperatures expand to cover large parts of the tropics. So we go from the black spots to the grey shaded area, and that actually covers enough of the planet that more than 3 billion people are projected to be living, say, around 2070 in a plausible 3 degrees warmer world at temperatures that hardly anyone experiences today. Now, are those people going to just stay there, or are they going to move? I think it's reasonable to assume that many people might seek a more tolerable climate elsewhere. I'm just getting some messages on the chat line for those of you who don't get to see it, telling me that you can't see my camera, but I can assure you it's turned on. So apologies if that's great. So now I'm going to move to show you what I mean by a tipping point. So this is a system a little toy system that I'm forcing to pass a tipping point, but it illustrates what's true of many different complex systems in the world, that they can have different stable states, But under forcing like global warming, they can be tipped out of one and into another, as you saw there, where in that case, in the cartoon, global warming was destabilizing the state we started in and eventually tipped a complex system into a different state. Now, there are lots of systems that can behave like this in the climate, but also in the human realm, as we'll see. So I spent a lot of time in the last 15 years trying to identify the bits of the climate system that could be prone to a tipping point, and I put them on this map about 10, 15 years ago. And they range from tipping or triggering the loss of major ice masses like ice sheets on the land in Greenland, or the Arctic sea ice on the ocean, or parts of the Antarctic ice sheet, especially the West Antarctic ice sheet. Also the possibility we can tip the loss of major bits of the biosphere like the Amazon rainforest, or we could tip a change in the circulation of the ocean or the atmosphere in the case of the monsoons. These are all serious climate risks, if you like. And of course, the question becomes how big a risk and which is the closest. So this is my cartoon attempt to rank the risks over a decade ago. And clearly, if we're going to do some basic risk management here, we need to know something about the likelihood of these different tipping points and their relative impacts. And the triple question mark is to highlight that whilst you'll see we've done some science on the likelihood of these tipping points, we've done very little work on what their true impacts would be. But just to give you a taster, earlier this year we published one study that took a very parochial view. It just looked very narrowly at the impact of one climate tipping point in one country, my own, and in one sector, if you like, agriculture. So the tipping point we considered was a collapse of the Atlantic Ocean's so-called overturning circulation. But in common language, that would amount to collapsing the Gulf Stream, or what I think is called the North Atlantic Current on the map on the left there. Now, that's the thing that gives us a relatively mild and equable climate in Western Europe at the moment. So if we lose that, we get certainly much greater seasonality and much more severe winters, stronger windstorms, and a markedly drier climate. And it's quite a lot of detail on the right, but what we're able to show is, well, absent that tipping point, climate change would be expected to change agriculture in the UK. Generally, it makes things warmer. It would allow arable farming in brown to spread at the expense of grassland, animal rearing, pasture farming in green. But there'd be a problem in the southeast where normal climate change makes it too dry for wheat growing. So then the interesting question is, what if you also overlay a climate tipping point? And in this case, well, by markedly drying the climate, it basically eliminates arable farming from the UK. But that would be the least of our worries, to be frank, because we calculated how much water would be lost and what a problem this would pose for water supply in the southeast, let alone those storms and other effects. So let me talk briefly then about the likelihood of climate tipping points, having given you a slight taster on the impacts. What this shows is abrupt shifts happening in state-of-the-art climate models as a function of warming above the pre-industrial level on the x-axis. And it comes from the Intergovernmental Panel on Climate Change's last report and that generation of climate models. And the striking result is within our best climate models, there are a load of abrupt climate changes happening that start at 1 to 1.5 degrees of warming, and they seem to cluster around 1.5 to 2 degrees above pre-industrial. And bear in mind, we're at about 1 degree of warming at the moment. And if you're wondering why there's not lots of abrupt shifts at higher temperatures, that's because there aren't many scenarios that go up to high temperatures. So you need to mentally just readjust this distribution, as lots of abrupt shifts would occur up there. But still, what's striking is the danger zone, even at 1.5 to 2 degrees of warming, perhaps an extra reason to limit warming to that level. So here's my little visual summary of how the Intergovernmental Panel on Climate Change, the IPCC, have been increasing the risk assessment of climate tipping points over time through successive reports as we go down the rows of the vertical there, so that now they would agree with me that we're in the danger zone, essentially, that at around 1 or 1.1 degrees of warming, we already see evidence that we may have passed some climate tipping points. And this is a little visual map summary of some of the accelerating changes that are going on in the climate system, in the elements of the climate system that I already identified a decade ago could be vulnerable to tipping. And the one where we have the clearest evidence that a tipping point may already be passed is for the West Antarctic ice sheet, where it seems to be in a form of irreversible retreat that's beginning and drains a part of the ice sheet that will give a little over a metre of sea level rise, but will destabilise the rest of the ice sheet that eventually would give us 3 metres of sea level rise. Whilst on Greenland, we can't rule out that that is very close to a tipping point. And if we lose that ice sheet, we eventually get 7 metres of sea level rise. And the only comfort here is what eventually means. At the moment, the timescale of those changes are millennial, but obviously the warmer the world gets, the faster the ice melts and the faster the sea level rises. So that's probably enough of scaring you on climate tipping points, but as risk professionals, it's probably also worth knowing that these bits of the climate system interact causally, and as we see accelerating loss of Arctic sea ice that warms the Arctic 2 or 3 times as fast as the global average, this is obviously contributing to the accelerated melt on the Greenland ice sheet, as well as thawing of the permafrost. That Greenland ice sheet melt is pouring fresh water into the North Atlantic, into the regions where deep water currently forms. But by making the surface water of the ocean fresher, it basically interferes with this deep water formation and this overturning circulation of the Atlantic that I mentioned, and is contributing to slowing it down. And we know from Earth's past that when you slow down that Atlantic overturning, what it does normally is it drags heat from the southern hemisphere to the northern hemisphere. You slow it down, you're dragging the band of rainfall all around the tropics southwards, disrupting the monsoons in the tropics, and you're leaving heat behind in the Southern Ocean, where it can contribute to melting the ice sheets there. In other words, we have something we sometimes glibly call domino dynamics, where tipping one thing is increasing the risk of tipping another. And you end up concluding that, oh dear, we might effectively be looking at the really stark risk that once you start this going, you're effectively have the possibility that you start to trigger a global tipping point. I don't think we're there yet, but obviously that's a massive risk we need to avoid. So let me change direction a bit and try and cheer you up. How are we going to avoid that risk? Well, I think we all know that we're signed up to the Paris Agreement. We need to try and limit warming to well below 2 degrees centigrade and aim for 1.5 degrees C. And basically, that means we need to try and follow the red curve on this slide. That is, eliminate all greenhouse gas emissions, CO2 emissions, by 2050. That is in 1 generation's time. And then carry on to a situation where we're doing net removal of greenhouse gases from the atmosphere for the rest of this century. That is a spectacular ask in terms of the rate of social and technological change required. And my basic thesis is the only way we're going to achieve that rate of decarbonisation is if we can find and trigger what I'm going to call positive tipping points in our social, economic, technological, financial, perhaps, systems. And there's a lot of work, not just by myself, going on now to work out what are those tipping points that can accelerate decarbonisation. So just to give you some context, it's well worth being aware that technology has changed rapidly in the past. This is the scene on Easter Parade, Fifth Avenue in New York City in 1900. Everybody's in a horse-drawn carriage. One lucky person is in an early automobile. 13 years later, everybody's in an automobile, and one perhaps unlucky person is left in a horse-drawn carriage. That's a transformation in modes of personal transport within a decade across all US cities that, of course, have spread around the world. Now, we need those kind of rates of change going forward, and things that can help propel or amplify this kind of decarbonisation technology change? Well, there are lots of well-known feedbacks in the uptake and diffusion of technologies. The more we make something, the better we get at making it, learning by doing. The more we make something, the more cheaply it can be made. That's crucial, economies of scale. And also the more we use something, the more technologies emerge that make it more useful. All these positive feedbacks or reinforcing feedbacks can come to our aid, as too can a social feedback that we call social contagion. Basically, our neighbours do something new, like put solar panels on the roof of their house, and then maybe several of us in the street think, oh, blimey, I'll have some solar panels. And then several more people look at us and think, I'll have some solar panels. And sure enough, this social contagion has been real, and it's been real for solar panels on people's houses. I'm showing you some data from part of Colorado in the US, where you're seeing in a 4-year interval the rapid spread of uptake of solar panels on roofs. A second example where we see this social contagion happening already is in the uptake of electric vehicles. And this is one case where we've already seen a tipping point in one nation, Norway, where through very clever policy design to the consumer, an electric vehicle is the same price as a petrol or diesel one. And sure enough, the Norwegian consumer has switched to preferring to buy electric cars. In the global picture, we're getting close to a global tipping point for electric vehicles because the price of batteries, the crucial addition to the cost of the car, is coming down all the time with economies of scale, such that within 5 years, absent policy, it's going to be the cheaper option to buy an EV. And what I'm really interested in, working with Simon Sharp here in the COP26 unit in the Cabinet Office in the UK, is how by some nations like Norway triggering this tipping point sooner, we then start to trigger what we call a tipping cascade, because the more electric vehicles and batteries you're making, the cheaper they get. And by making batteries cheaper, it opens the door for other tipping points on our sketch here. Particularly important was the possibility, so I'll just go back, that this opens a window for renewable electricity for balancing out supply and demand, because you need a lot of battery storage in the grid. And the good news is we're heading for a renewable power tipping point anyway, I think. So my second example where a tipping point's already happened is shutting coal out of electricity generation in the UK. Bit complicated, but I plot a red line here, which is the price at which you switch from using coal to generate electricity to using gas. And on the grey shaded area is the carbon price from the EU trading system, and the blue shaded area is the additional carbon price that the UK government put in this sector. And at some time around the end of 2015, this carbon pricing triggered gas to take over from coal in the merit order of electricity generation, and it radically changed the economics of coal production in a way that actually led to the decommissioning of coal power stations, an irreversible decision, and a drop in the contribution of coal to electric power from 40% just about 5 or 7 years ago to about 2% last year, and possibly closer to 0% this year in the UK. Looking wider, we're looking towards a tipping point in renewable energy because of the spectacular economies of scale that solar photovoltaic cells in particular are going to be able to generate. They're already generating electricity cheaper than fossil fuels, and they might be generating them at the 10th of the price, or at least a fifth of the price of fossil fuels within a decade or so. So perhaps we shouldn't be so surprised that in the first half of this year, what I show on this map is that if you take subsidies and tax credits out of the equation, renewables are the cheapest way of generating electricity already in large parts of the world. Yellow for solar PV, blue for wind power on or offshore, and only the grey and the black regions still have fossil fuels cheapest. So again, working with the COP26 team, we're really looking at what are the deliberate interventions that can trigger these tipping points to happen sooner. And by some countries shutting fossil fuel generation out of power generation, again, economies of scale kick in, such that within a decade, major economies like China will be at a situation where it makes economic sense to shut down a coal-fired power station with useful life left in it and replace it with renewables. That's already true for a gas power station in China, by the way. So to wrap up, the important thing to think about in the solution space is there are these tipping points and there are these cascades and there are these feedbacks that can propel things to happen faster. And what I'm suggesting here, for example, is that the rise of renewable electricity power is going to feed back into this transition to electrification of transport, which is in turn making batteries cheaper, which in turn makes renewable power a more stable, preferred option. So I can leave up my summary slides, but the basic message is on the bad tipping points. At the moment, we're heading for 3 degrees of global warming. That's a human catastrophe if we decide to go there, but it's also a major risk of tipping several climate tipping points. And if we are serious about limiting warming to well below 2 degrees C, we're going to need to find these positive tipping points in the society and economy to propel these transformative rates of social and technological change. But I hope I've shown you that those tipping points really exist and they're starting to happen. Thanks very much.
Tim, thank you very much indeed. We've got lots of questions coming in for you, so we've got some time left where we can pose those. First of all, our early starter this morning posed this question. If and when solutions are adopted, how long will it take to achieve and sustain 2 degrees C?
So if we could follow the kind of abrupt decarbonisation trajectory I was talking about, then what we'll be doing is limiting the warming at or below 2 degrees C. That temperature was, because of what we think of as inertia in the climate system, is probably going to be reached. At least 1.5 degrees C is definitely going to be reached by the 2040s, if not sooner. And we may well exceed it and then peak and then decline the temperature if we're in the best case scenario. But we'd be looking at a little bit over 1.5 degrees C mid-century in the best case scenario, but then we might get back to 1.5 degrees C in the second half of this century if we can manage this large-scale removal of greenhouse gases from the atmosphere. So that's the best case scenario. But if we were to carry on the current trajectory, then there's a risk we're at 2 degrees C by 2050-ish, and we just carry on up from there.
Okay, thanks very much. And you talked a little bit about electric cars, which I guess are also to some degree linked with autonomous transport. Are they truly more environmentally friendly when you take into account the pollution from mining? And also, is there any sort of issue there about local people being deployed by large corporations that you could comment on?
Yeah, I think it's a great question. I can see it from Amanda on the slide. Yeah, I share some of your concerns there, that like every new technology with new resource requirements, there are these important factors that have got to be considered. In fact, there's a serious question about, have we got enough lithium in the ground for all those lithium-ion batteries? I chose those examples, but I could also have chosen hydrogen power as an opportunity to tip accelerated change, and it's still not totally clear whether we won't end up with a mixture of electrification and hydrogen fuel cells in transport to try and mitigate some of those issues and risks. They would be true of any technology, of course, and one could easily cite the many bad impacts of coal mining on human health and enslaving some populations and so on. So take your point very well. And I guess the crucial thing in the bigger picture is actually we need to shift from a extractive material economy to a circular economy, to using renewable energy to make new things out of the things we already have, to cycle the materials we have. But clearly, if we've got to transition infrastructure, we've got a transition to do before we can get to that point.
And Tim, on the subject, while we continue the theme of energy, and we've talked there about the role of electric vehicles, what about the role of nuclear energy in reaching the Paris Agreement? What role do you feel that has got to play now?
Well, I trained in physics and natural science, so although I recognise risks from nuclear energy, and I recognise its link to nuclear arms in the past, I think it could have a role to play in supplying what we call the baseload electricity. Certainly is doing in France and has been doing for decades. And I'm encouraged by the new technology of thorium reactors that really do quite a good job of disconnecting civil nuclear energy from making weapons grade material. So I'd be open to that, but I think the decider isn't me, is it? It's society, which takes a very bizarre, in my view, risk assessment of nuclear power. Society is totally unable to do an accurate risk assessment of nuclear power versus fossil fuels, where coal burning and coal mining has killed many, many more people, either through the mining or through the air pollution, than nuclear power ever has.
Interestingly, I mean, we're talking here about climate change, which is one of the big megatrends in the world. And I knew it wouldn't be far away that we talk about one of the other big megatrends, which is geopolitics. So let me phrase the next one about the world that we live in of protectionism. Brexit, we're still struggling to agree a deal with our mainland continent colleagues. The US election maybe has had a bit of a change in direction of protectionism with a new government coming in, but the US-China disputes are still there. So how big do you think the hurdle is for protectionism in getting a collective global response to some of the issues that you've raised?
Well, it is possibly the biggest sociological hurdle, but I think it's perhaps inevitable that as climate change becomes one of the defining issues of our time, so in politics there will be a reaction against that to maintain a different sort of narrower, perhaps parochial, nationalistic and closed borders approach to the world. And then there'll be others who, like me, will advocate for needing global solutions to a global problem, needing an openness to the future movement of people, because that can be good economically, but it's essential for collective human well-being. This is the political battleground drawn at the moment, as you lucidly point out. It's up to us, as in a democracy, to vote one way or the other, if you like, and make our voices clear. I'm not going to dictate the rest of the audience's views, but I think I made my own clear. And if we do get this kind of xenophobic protectionism dominating, then we're in deep trouble.
Thanks very much, Tim. We're sort of up for time, and I'm really sorry. We've got some great questions coming through, so we may contact you afterwards to see.
I'd love to answer all these questions flooding through, and I would write them in the chat, but I'm not sure everybody can see that. But I'll happily answer them in a follow-up. So thanks for your engagement, audience.
Yeah, we'd love to do that. And I've got a final question for you, which is sort of in two parts, really. And that is, based on everything that you've said, the world that we've lived in the past year with the impact of the pandemic, as we hopefully start to emerge from that next year with the introduction of vaccines and the world becomes a slightly more optimistic place on climate change and what you've said today, are you an optimist or are you a pessimist?
I have to be an optimist and try and show the positive tipping points way forward, because I can't look my children in the eye otherwise and level with them on this. So I'm not a naive optimist, I'm a sort of pragmatic one. But that's why I'm trying to do everything in my power to say that there is a path that can get us to a flourishing future without the worst impacts of climate change. But we have to make conscious decision and action now if we want to go down that path. We can't faff, we can't wait. And I think this shock from COVID is a great opportunity to reorient and choose a different path forwards. So I won't be resuming any international travel to give talks. I shall maintain my presence in speaking online, and I'm doing a few other things to further minimise my personal footprint. But clearly, we need these partnerships across sectors to move the dial here, and we've got to make a commitment together to say, yes, we're going to take this transformative path because it's going to be great for us as well as solve the climate problem. Thanks.
Tim, thank you very much. I mean, it's a very dangerous thing for you to say about presentations, because no doubt you will receive an invitation for a repeat performance. So thank you very much indeed for opening our event today.